Hello viewers, today we will discuss unit and dimension. What is the unit? For any physical quantity, we always fixed some standard measurement, and that standard measurement is called the unit. There is the two type of unit is present. One is fundamental unit and another is derived unit. In that fundamental unit, there is one is present that is called the dimension. What is the meaning of dimension? Dimension of physical quantity are the power to which the fundamental quantity must be raised to represent the given physical quantity. That means there is a fundamental quantity is present, up to which extent it is raised, that will be determined with the help of the dimension. For example, dimension of mass. There is the dimension of mass is denoted by in that way. Dimension of mass is m, length is l, there is a capital L, there is the time, that is the t, current is denoted by A, there is the temperature, that is the K. Now, for example, dimension of area. The area is equal to length into breadth. Now here just see the length. Length is denoted by L. Now breadth is also a length. So it is also a L. Now the area A, that is A, is denoted is equal to L square. Now dimension of velocity. Now velocity is equal to distance by time. So the dimension will be L by T, that is L T to the power minus 1. That is the dimension of the velocity. Now acceleration. S is acceleration. What is the meaning of acceleration? Acceleration is equal to velocity by time. Now velocity. What is the dimension of velocity? That is L T to the power minus 1 by T. So there will be L T to the power minus 2. Now, what will be the dimension of force? The dimension of force is equal to mass into acceleration. Now mass, what is the mass? There is the mass is denoted by m, and at that acceleration is L T to the power minus 2. Now next is there is the force, there is power, work. What is the dimension of work? Work is equal to force into displacement. Now dimension of force is equal to ml T to the power minus 2 into L, that is m L square T to the power minus 2. Now in that way we can, that all are the physical quantity, velocity, acceleration, force, work, there is so many physical quantities present, and in that way we can find the dimension of different physical quantity. Now there is the uses of dimension. There is the 3 or 4 uses of dimension is present. One is to check correctness of physical equation. To check the correctness of physical equation, there is a one term is present, principle of homogeneity. Now what is the meaning of principle of homogeneity? The dimensions of each term of both sides of the equation must be same. Dimension of each term of both sides of the equation must be same. For example, S is equal to ut plus half at square. S is equal to ut plus half at square. Now there is here S is equal to ut plus half at square. Now what will be the dimension of S? What will be the dimension of ut? And what will be the dimension of at square? We find out. Now S is equal to ut plus half at square. Now thus what is the dimension of S? The dimension of S is L. Now ut, what will be the dimension of ut? U, that is the velocity, L T to the power minus 1 into T, that is L. Next, half at square. Half at square. What will be the dimension of half at square? There is the half constant term, it has the no dimension. There is the a. L is L t to the power minus 2 into t square. So that will be the L. So just see each term S is equal to ut plus half at square. Now S dimension L. Now what will be the dimension L? Now what is the dimension? That is L. So here the each term has the equal dimension. That is the dimension of S is L. E that ut that is the dimension of E is L, and at that is the dimension is L. So we can say that the equation is true and it is right. With the help of that we can prove that it is dimensionally correct. Now so we can conclude that L plus L, L plus L, that will be L. L minus L, that will be also will be L. What we learn basically in mathematics, L plus L is equal to 2L, L minus L is equal to 0. But in the dimension, that L plus L is equal to L, L minus L is equal to L, because each term will be dimensionally equal. That is the principle of homogeneity.
Go.
Now, the second use of dimension, that is the conversions of units. For example, we convert to one unit to another unit. For example, we convert to dyne to arc, dyne to Newton, or joule to arc. If we convert that one unit to another unit, so there is the one system is present, the product of the numerical value n, that is the numerical value n, and its unit, that is the u, is always constant. Suppose dimension of a physical quantity are a in mass, b in length, and c in time. Then there is the numerical value of one system is n1 and another numerical value is n2. And if there one in one system, if m1, l1, and t1 is the different unit of the physical quantity, and another system is m2, l2, and t2, then there will be n1 into m1 to the power a, l1 to the power b, and t1 to the power c is equal to n2 bracket m2 to the power a, l2 to the power b, and t2 to the power c. That is the formula. With the help of that we can convert dyne to Newton. Dyne is the CGS unit of the force and Newton is the SI unit of the force. So we can, with the help of that unit, we can convert one unit to another unit with the help of the that formula.